Good morning, ROSCon. I was delighted to be slotted in between Dirk's Build Farm talk and Alex Henning talking about CI on hardware. We're all very topical. So I'm just going to kick off a demo here while I do the bulk of everything from slides. So this is me shelled into a VM that we're running in Kitchener. So I'm going to build the demo that's available on GitHub. It's kind of a 3.0 version of what we run internally. The packages that we built that implement these concepts were kind of intended to be open sourceable, but certain assumptions changed and it ended up really tied to some of our processes, so it made more sense to just do a minimal demo. Anyway, so what this is building is a bundle of all of ROS desktop full. So you can see that all of this will make more sense once we've actually talked about it a little bit, but it's getting the ROS distro cache, and it's going to build up a workspace of about 200 packages, and it's going to build all of it. So this is not equivalent to building the 2,000 packages in the distribution, but the fact that this takes only 10 minutes is significant, and I want you to think about that in light of Dirk's comment about building the whole thing in like a whole day. So, and I've got my extended desktop thing going on here. Okay, so ROS bundling. I'm going to quickly talk about the history, how we made it here, what the problems were that kind of drove it, and then the design of what we're doing and where we hope to take it in the future. This actually started 2 years ago with me trying to install ROS on my Mac, which is something that many of you do. I see Macs out there, and a lot of awesome work from William and others have made this possible. But it is significant when you look at this page of instructions and you see how much of it is like, this is what to do, and then all of the random things which you might have to fiddle with or like sudo edit whatever to like make it work. And so about 2 years ago, I made a gist that was basically like, here are the instructions I think will work for me. And there were some kind of philosophical differences, like my approach used brood Python instead of system Python and whatever. But there was a very explicit note at the top. These instructions are not a script. Paste them into your terminal one by one. Don't just download this and run it. But everybody did that anyway. So I ended up moving it to a GitHub repo a year and a half ago, and then it has kind of iterated, and now that Travis actually supports building on OS 10, there isn't enough time on the Travis builder to build everything, but we kind of build up to ROS base just to kind of prove that it mostly works, and that covers PCL, which is by far the source of most of the problems. So anyway, just to kind of like give people an idea of what goes on in there, ROS install generator is able to take that package, and then there's a few flags that say which distro you want, and then you tell it you want all the dependencies, and you want tars, and you put in a ROS install file, and then WS tool is able to populate that workspace with all of those repos. And then we use ROSstep to install dependencies. This is the OS 10 version. And then catkin tools is able to build that massive workspace. So Dirk talked a little bit about catkin make and catkin make isolated. Catkin tools is the kind of successor tool which is not quite complete enough for OSRF to recommend it for everybody. But philosophically, it's catkin make isolated in that each package gets its own CMake invocation, but it will track dependencies and run things in parallel where it's able to. So if you look at this output, it will run catkin first. Then once catkin finishes, it kicks off 4 other packages and then carries on from there. And I think that's limited more by the fact that I have 4 cores on my Mac than anything else. But anyway, that's that. So the ROS install generator tool generates this ROS install file, and it's got tarball links in there. And so you can see for each entry, it's saying this is the name of the folder you should use, and then this is the tar location where you can get that. So the source of that information, as Dirk kind of mentioned, is the distribution YAML file, as with the build farm. And so what happens is the ROS install generator is able to use that source, and it will grab it out of the GitHub URL for the GBP repo that Bloom is generating, and then ROS install generator, when you use that tar flag, it has logic in it that says, oh, a GitHub repo, I know what tarballs look like for GitHub, and then does that, which there's no standard kind of scheme for converting GitHub into a tarball, but downloading tarballs is crazy fast compared to actually cloning Git repos, particularly big Git repos. So we recently contributed an extension to ROS install generator that also supports Bitbucket and GitLab for this. So the other kind of interesting thing here is how the deps flag works. So if you kind of think about that, like the deps are expressed in package XMLs. So on a kind of package by package basis, you could say, oh, clone me this one repo, and I can look in the package XML and see these are the things it depends on, and then you could go back to the distribution YAML and find those repos, and then clone those, and then look in them, and it would be like a super insane process. So the way that kind of resolves itself is that there's a distribution cache file, which the build farm builds, which is that distribution YAML, except it's got a giant dictionary in it of every package XML. So this is like a little snippet of that, and you can see action lib with like build depend, run depend, whatever. And so that distribution cache is updated by the build farm every 5 minutes, or 15 minutes, whatever it is. And so ROS install generator is able to access this file and then resolve dependencies for a whole tree of packages. So that's kind of like historical piece one. Actually, I'm just going to jump out of this to check how my thing is doing. Okay, so this is our source deb that's been generated, and now we're going to just start building that. So cow builder is a standard scheme for converting a source deb into a binary deb. And resume. Okay, we're back. So the other kind of historical context is about sort of 2 years ago, ClearPath committed more heavily to a pivot into the industrial logistics space, and then a year ago I entered that team. And I have had a long tenure working with research products, and I love it. What we find, though, is that researchers are really enthusiastic to be on the bleeding edge of everything and don't care so much if stuff breaks every now and then. And the whole idea of like, oh, you had a problem and the solution is to upgrade to the latest bleeding edge is totally acceptable. And in the industrial world, that is totally not acceptable. So that was a big part of what had kind of driven some of this idea. So the specific problems, rolling release. The core ROS packages that OSRF maintains, they are very disciplined about not breaking APIs, and if you try to commit a pull request that inserts an argument into the middle of a function, expect Dirk to like smack you down. But internally, I mean, sort of from a sort of philosophical point of view, ROS Indigo is a rolling release. If you sudo apt-get install ROS Indigo desktop full today, you're going to get a different thing than you got 2 months ago. And so just from that sort of point of view, it's not a frozen thing. And that was a real difficulty for us. Yeah. So the other thing is highly coupled repos. And I've actually had a number of interesting conversations with people this weekend, and it's been fun to find out where others have landed on this. A big issue for us is we would have systems of functionality which would maybe be logical to group into a single repo, but they'd end up separated for kind of reasons external to like the immediate development. So an example would be our controls team has their code spread across 3 repos. The repo containing MoveBase, the repo containing a planner, and the repo containing a tracker. The MoveBase repo is forked from public. And we don't want to just clobber those 3 repos into one, because at least for an extended period of time, there was a vague vision that our changes to MoveBase would be pushed upstream. We gave up on that. But there was this idea that there would be a public release of it. And so there was a very good reason to maintain 3 different repos. And yet, we would constantly have this issue of, okay, well, I changed something and it's spread across 3 repos. And in order to get my devel jobs to pass, I need to create blooms of these other things. And so people would bloom stuff all the time that wasn't really in like a releasable state. It was just blooming for the sake of keeping the system kind of functional. So coupled repos. Our release process was basically, okay, here's the current state of testing, and we're going to snapshot it, and that's our like 2.0 release or whatever, which is very analogous to the manual sync operation that Dirk talked about in the build farm. But that obviously gives us a huge problem if a customer has code that we deployed to them 4 months ago and we need up to +1, just a handful of packages for an incremental fix, and they're not interested in being on the latest bleeding edge. And I see that there are other ways we could have dealt with this, but just kind of bear with me. Meaningless package releases. So this is the other thing. We're based in the Waterloo region, and we have a major phone manufacturer there that has hemorrhaged a lot of people over the past couple of years, and so we've inherited a lot of kind of phone development mentality. And my actual title at ClearPath now is the Firmware and Integration Manager, which is fascinating that I ended up doing all this infrastructure stuff, but I kind of justify it on the basis that from our perspective, increasingly the robot is one giant embedded target. And so if you kind of squint funny, every piece of code that's running on the robot anywhere is firmware. And so that was this kind of idea that we didn't want to deal with source workspaces on the robots. We wanted as much as possible to always be deploying a binary. And so that was also an issue that people, developers would be like, oh, it's going to be a pain in the butt to go and shell into a robot, so whatever, I'll just bloom a release, and then the test team will tell me if it broke, and so you can imagine how that turned out. So anyway, we had this idea of the bundle. And so my colleague Jonathan and I sat down, and we kind of had this idea, let's centrally build a big workspace with all our stuff, we're going to tar it up, and then we're going to put that on the robots. And initially it was focused on this testing thing of, okay, we'll just have a ROS install file that'll cover like the stuff that usually breaks as opposed to everything. But then we changed our minds. And that was partly from the experience of ROS install OS 10, where we said, it's actually not that big a deal to just ROS install generator the whole world and build all of it. And we said, we're going to need to version that thing, and we might want to, GPG sign it, and we'll probably want some kind of scheme for distributing it. And it turns out that deb packages have that all covered, so we'll do that. And then we said, if we're going to do this for the robots anyway, why don't we just also use it for developers and our CI simulation environments and all of that kind of thing. And so part of the choice of a deb package was just familiarity, that it's something that have had a lot of exposure to and a lot of exposure to the tooling, and the tooling has been around for 20 years, it's very mature. But we did kind of briefly consider some of the other options, and I know others here are doing a similar concept with a Docker container. But if you kind of look at the various ways that you can deploy like a big blob of stuff, and like a virtual env is kind of solving the same problem, where you say, I want this isolated environment for Python that's kind of distinct from all of the system Python packages. Chroot is the same idea. Docker is that, except you're also isolating at the kind of port level. And then Vagrant is like a VM, where then you're further isolating at like CPU level. And so Catkin kind of fits in at the virtual env level. You could say, sort of, again, if you squint funny, like Catkin is basically like virtual env for CMake packages, kind of. And so kind of the problem that we wanted to solve was just getting a blob of files onto the robots or desktop computers. We weren't really interested in this business of trying to isolate things or installing multiple apps or dealing with any of that kind of stuff. And so a deb package was the simple place to start. Very small sidebar, deb packages are compressed with the XZ utility, and it's awesome because it has high compression. It's also single-threaded and crazy slow. So if you have a thing that's like 2 gigabytes and you try to compress it, it'll take like forever. So if you do this, you should go to my PPA, where there's a parallel version of dpackage that's super fast. So if you do this, do that. So just to quickly talk about our tooling, we have this ROS bundler tool. We have a bundles YAML that says, this is the name of the bundle, and these are the packages that go in it. And then we build that into a DSC, and that was what you saw at the beginning. And then CowBuilder builds it, and we get debs. So we've talked about most of this stuff. This is the tool that's analogous to Bloom in our workflow, where we're creating the rules and control files and kind of transforming the upstream source into something that the Debian world understands. So to control the version, we will tag our ROS distro repo. So that is a little bit of a departure from upstream in the sense that upstream has like separate directories for the different distros. We wanted to use the branching tagging model in Git. So all of our code is ROS Indigo, but we have branches in our ROS distro that correspond to our kind of major releases. So we do a major release every 2 months, and then we can tag it as we're proceeding through our testing process. We use the Debian changelog, so the version that's in the changelog, it will be what corresponds to the tag in the ROS distro repo. So just to really underscore that, that's the big takeaway here. Each major release of our software stack is a tag on ROS distro that corresponds to a changelog entry. So our kind of process with these 2 initial steps is to grab that ROS distro repo at the appropriate tag and then refresh the cache so that we get dependency resolution correct for the specific tag that we had. So that gives us 2 bundle types. We have a pre-release bundle, which is kind of equivalent to testing debs. It's just the newest of everything. And then we have a release bundle, which is the fixed versions based on a tag. The really cool thing, though, that we have like 3 minutes to talk about is the devel bundle. So the devel bundle is based on the source branches instead of the release branches. There's another flag for ROS install generator, which is upstream development. Upstream development will get you the source from the upstream source repo instead of from the Bloom GBP repo. So this cuts Bloom out of the picture. Sorry, William. The devel bundle is really neat because it's giving us all of the devel branches across the entire ROS distro for what we're doing. And it was kind of one of those things that we approached with fear and trembling. We were like, is this totally insane to be doing this? It's worked out really nice, and it's actually improved our relationship with upstream too, because it means that when we detect a breakage, when something merges into ROSCon, we detect it right away. Like, you know, I think something broke, like ROS topic broke or something recently. There was a community contribution, and like 12 hours later, we were like, this broke. And then like 4 hours after that, we were like, and here's the fix. And it was very motivating because we got the fix in, and then our devel bundle rebuilt, and we had the fix right away. We didn't need to wait around for it to be bloomed and built and synced, and you know, it just took out that whole kind of 1 month turnaround. So this is a little bit more into like our internal methodology, but we basically define like a robots bundle, and then Nimbus is the name of our fleet manager. It's like a cloud joke. And then so for each of those, we have the flavor, which is kind of like the overall version, and then the develop, pre-release, and release. And so that's what we build. So we have an internal Jenkins thing, and since I've started to wrangle Jenkins, I have a deep appreciation for the infrastructure team at OSRF who deal with that. So we build those, and then we push them into Aptly. Aptly is really cool because it lets you retain old versions. So we can have, these are the, I don't even know what it is, the pre-release bundle. So this is Rocksteady's the name of our robot. So we have a pre-release bundle, and so if something merges that breaks, and you're like, darn, then you just sudo apt-get install the previous version, you roll back, and then the developer can fix it for the next day. You don't have to worry about freaking out and doing a last-minute fix and then blooming again, and which is what we deal with. So what we do is we have a status page, which is a little bit analogous to the status page that Dirk showed for the build farm. The kind of key difference is that this is repo-oriented rather than package-oriented. So the 2 columns are showing the current release version. So the first column of release numbers is a tagged release, and then the second column is the current kind of master. So you see action lib at the top mutated from 111.5 to 111.6. So that's telling us since the most recent tagged release, this package is mutated. So if we tag a new release, this is going to be a change that will be in that package. And the number, and then the blue box is showing the development branch, and then the number on the right is showing the number of commits that have gone in to the devel branch since the last release. So if we pop one of these open, we see, okay, in Katkins since 0618, the following 3 or 4 changes have gone into that repo. So that lets us do things like, as we're approaching a release, we can see, oh, in our devel bundle, we've been depending on these changes that we now really need, and so we can either internally or externally hassle a maintainer to get something bloomed, or if we can't get it bloomed externally, we'll just bloom it internally in order to get it into our release. And then quickly, I want to talk about ROS distro freeze source. We contributed this to the ROS distro Python repo recently. This lets us do this fun thing where we look at the source repo entry in distribution YAML, and you have the version, which is Indigo develop branch, and we can transform that into either a git hash, which is what you see above, or the tag that corresponds to the latest version below. So this lets us do fun things, like once we have a release, sorry, there's been some redacted content here, but if you look here, our 2.1 release that we executed, and then you see Atlas is the name of one of our repos, and that mutated between 2.11 and 2.12, and then it mutated again between 2.13 and 2.14, and there's a devel 2.1 branch where that mutation is taking place, but all of the other repos that aren't mutating have been frozen to their most recent tag. And so that allows the devel branches on those repos to march forward, and we can continue to build a devel bundle even of a past release. So I'll just quickly pop back. I think I'm about to get kicked off here. But we can see here, this is the demo that's completed. So we had a big catcontools invocation, the whole thing built in 10 minutes. Obviously, that's partly because of Ccache, but we can now, I'm not going to bother inserting the package into an actual app repo, but there it is, the whole desktop full SDK in 43 megabytes. So once we did that, we were kind of like, oh, it's a slam dunk. We'll just build this every day and distribute it. Why would we bother trying to do Delta anything? So there you go. And that repo there builds on Travis, so you can examine the output without even downloading it if you like, or you can download it and run it locally. Quickly, in the future, catcontools is amazing. I'd love to see it do more things. Specifically, I would love to see it build docs. It would be really nice to be able to have a ROS install generator workspace and then just build docs for everything in the same kind of parallel manner. There's an existing ticket for that a bunch of people have thumb-upped. I'd also like to see a better story for running tests under Catkin. One of the things that we do is run tests against the devel bundle. So that means that it kind of breaks that dependency problem where we can say, we install the devel SDK and then we have a kind of an up-to-date underlay that we're running our tests against. And then once again, our kind of like medium to short-term plan is to drop Bloom altogether. So we'd run exclusively from source branches. I'm still kind of sorting out exactly how we deal with that. Obviously, Bloom is an incredible tool that allows OSRF and ROS to support many different operating systems. We don't care. We support one operating system. And so that's part of why we can do this. So we might need like an extra release version attribute in the distribution YAML or something. I'll probably have a fight with Dirk about that later. And then the last kind of piece is, in the fullness of time, we probably will investigate migrating to snaps. For this, snaps do a lot of things that are very compelling. Packaging it as a squash FS prohibits people from going in and diddling with it. The Delta updates are fantastic. Multiple release streams gets us out of that like devel pre-release release because it's handled natively. But this is currently blocked on the store entity from Canonical being not yet open sourced. So there we are. Thank you to William and Dirk who maintain all of this stuff and tolerated my crazy pull requests. And John who worked on catcontools, Nicholas who worked on ROS install OS 10, and Mike Ferguson for BuildBot ROS, which we used for a long time and was great and taught me all about Debian packaging. And ClearPath for being awesome. As you heard, we are hiring. Sure, yeah, so come and find me if you're interested to discuss further.
Okay, thanks, Mike.